Let's talk about some common parent functions. Well, first of all, let's talk about what we mean when we say parent function. You may have studied before or are about to study basically this idea where you're going to be taking a function and moving it around. So just very quickly, just kind of giving you a heads up for where this is going. Let's suppose I have some function and it looks like this, which will be a parabola. And then I want to move it, I want to translate it, or I want to change its shape somehow. So we can slide it over and down. So like we'll say that, and it's a little bit skinnier. It got slidden over and down. So this would be the parent function, and we don't really say that's the child function, but the fact of the matter is, parents often pass along their traits to their children, so children look like their parents, often. This looks a lot like that parent function. That's where this is going, but before we start moving things around like that, getting all crazy with it, let's just talk about 5 very common functions that we need to become familiar with before we start doing other things with them. So, first one you have seen many times before, and it's going to be this, y equals x. It's just a basic line. It's a direct variation line with a slope of 0. Let me explain what I mean. Let's make a little table for each of these. That'll kind of help us understand what the graph looks like. This one's going to be very basic, so -2, -1, 0, 1, 2. I'm going to go quickly on this one. In this case, y equals x. So whatever I have here, because they are the same, because that's what equals means. So -2, -1, 0, 1, 2. So we're going to draw a graph for each of these, and we'll make it as straight as we possibly can. So 1, 2, 1, 2, 1, 2, 1, 2. And we're going to plot all the points in our table, see what it looks like. And then in addition to that, we're also going to figure out if each function is increasing or decreasing, where it is, what the domain is, what the range is, and where it is positive, where it is negative. And we're going to talk about those things as well. We'll do that over here on the side. So first, let me grab a green marker and plot these points. So -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. You can see where this is going. You've seen this line before. And it goes like that. There we go. So clearly a line. I would write down the word line, but you know what it is, so I'm not going to waste your time with that. But what you learned way back in the day, let me hook a few markers together. What you learned way back in the day was how to move this around, which is where this lesson is going eventually. We're going to take things and slide them up or slide them down, or we're going to change the way they tilt and their slope and the way they look in that regard. So this is the basic parent function for a linear function. So let's come over here on the side and let's write down the domain and the range, and then we'll do some other things as well. So D for domain, R for range. I want to know what x values I use. Well, the x values, I'm kind of following my hand here along the x-axis. I use 0, -1, -2, -3, -4, -5, -6, and when I do, I graph way down here, but I'm using all these x values, and I use all these because it goes on forever, right? So I go from -infinity to infinity for my domain. My range, those are the y values, those are my outputs, and it goes 1, 2, 3, 4, 5, 6, because it goes up because of that. And it goes down because of that. So -1, -2, -3, -4, -5, and we could count down forever. So -infinity to infinity. So there's our domain, there's our range. Let's also talk about where it is increasing or where it's decreasing. And in this case, if you were driving up this hill, then you would be driving up this hill. It's going up the entire way. So this is increasing along its entire domain. So from -infinity to infinity, this thing's going up. So -infinity to infinity, it's going up. So I would say, where is it decreasing? Well, it's not. It's always going up. And then let's also talk about where this function is positive and where this function is negative. We're going to have a couple things going on here. So the function is positive. Let me grab some paper and I'll show you. The function is positive where it's above the x-axis. So just what you see here. So that happens, well, it happens from 0 onward. Actually, it does not technically happen at 0. We'll talk about that in a second. But it's positive for this section. And this section, the x values that correspond to this section are 1, 2, 3, 4, 5, 6, 7, 8, all the way to infinity. So from 0 to infinity, let me make that more parenthetical. It didn't look like a parenthesis, but it is. So from 0 to infinity is that one. All right. Now, I'm not including 0 in that because if I'm going to talk about where it's actually positive at an x value of 0, then the y value is also 0, and 0 is neither positive nor negative. Okay, let's talk about where it's negative, and I think you can see where this is going. So right there, it's negative for this piece, and this piece has x values that are over here. So negative infinity to 0, but not including 0. So there we go, negative infinity to 0. All right, there's our first parent function. The rest of these will go a little bit faster, and we're going to do 4 more, and we're going to start moving a little bit more quickly. So here goes. I'm going to erase this. So if you are writing down what we're doing, then you're going to need a table with these values in it. We're going to change the function. We're going to need a new one of those. We're going to need a new domain, a new range, increasing, positive, negative. We might even need a decreasing. So I'm going to put this in, and I'll keep all this stuff up, problem after problem. Okay, so the second one we're going to talk about is, if I can get the lid off, x squared, which you have seen before. All right, you know what this one looks like as well. Let me just go ahead and start drawing a few things here. 1, 2, 1, 2. I know where it's going, so those are the lines that I put. Negative 2 squared is positive 4. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And we'll plot those points. I'm going to start moving a little bit faster now. So we grab a green marker. We're going to plot negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. And notice it's symmetric over the y-axis. And so we're going to draw this thing, and we're going to call it what it is. It's a parabola. So here we go. There it is, and it goes up forever. It also goes left forever and right forever. So it's going up, but it's also going to the left as it goes up. It's just got this weird slope to it. So I'm going to write down parabola, P-A-R-A-B-O-L-A. And let's talk about domain, range, increasing, decreasing, positive, negative. This stuff should probably go pretty quickly. So here goes. The domain of this, all the x values that I use 0, negative 1, negative 2, negative 3, negative 4, it's way up here, negative 5, way up here, negative infinity, it's infinity up here. So I go from negative infinity to all the way over. So as I go over, a graph exists. For any x value I pick over here, there's a graph way up there somewhere. So there it is. Okay, the range is the y values that I'm using. What I used to do was I'd take my hand and I'd slide along the y-axis until I saw a graph. So no graph, no graph, no graph. Oh, I see the graph, it's green. And it goes from 0 and upward. So from 0 to infinity, and I don't know why I'm switched to green, but whatever. From 0 to infinity, we'll go with it. Range is green for some reason. Okay, it is increasing, not here, but it is increasing here. And it's going to be increasing starting at 0 and going forward, which means it's going up. So it's increasing from, let's go red, why not? From 0 to infinity. There are some individuals that would be like, maybe it's a bracket, maybe it's a parenthesis. Mathematicians are not going to beat you up over that, okay? I'm going to put a parenthesis because technically at 0 it is neither increasing nor decreasing, but somewhat irrelevant. Okay, changing colors, I don't know why. Decreasing here, decreasing from negative infinity, and as I say negative infinity, I'm thinking of all the x-axis that's over here that has a graph that corresponds with it, okay? So negative infinity all the way to 0. So negative infinity all the way to 0. I'm not going to include the 0. If you do, no one's going to beat you up. Positive, negative. Where is it positive? Well, it's never negative. Okay, so let's just go ahead and say that this is not a thing. So there are no intervals, none. None of the intervals will give you a negative value of the function, but there is at least one interval that gives us positive from, well, basically the whole thing. Like the whole thing is positive. So this piece is and that piece is. And you could say, well, is it negative infinity to infinity? I want to say no. I'm going to say that this thing is positive everywhere except at 0. With an x value of 0, you get a y value of 0. And again, 0 is neither positive nor negative. So negative infinity to 0, and we'll put that little math symbol in the middle, the union symbol, from 0 to infinity. I don't know why that one was green and not red. Who cares? Okay, there's the second one. I'm going to keep moving very quickly. We're going to move to the third one. If you're looking at that dot right there and it's bothering you, it's a scratch on the board. So if you're like, why is that decimal in the middle of nowhere? It's not a decimal. Okay, the next one is going to be x cubed. All right, let's start cranking out answers. Negative 2 cubed is 8. I lied, it's not. It's negative 8. Negative 2 times negative 2 times negative 2 is negative 8. Negative 1 cubed is negative 1. 0 cubed, 0, 1 cubed, 1, 2 cubed, 8. Done. Okay. 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This one's hard to draw. Let's erase some stuff here. And here we go. Okay, let's start drawing one of the most difficult graphs in math to draw. Okay, 0, 0, that was easy. 1, 1, 1, negative 1, 2, 8, negative 2, negative 8. Okay, this one does this really funky thing that we can't really see based on the numbers we have here, but it does this funky thing at the origin. It's going to come up and it's going to go and then come right back up. All right, so it's going to come up, and then right here it's going to level off almost, and then, whoa, it went astray here. Let's fix it. And then it comes up. There we go. And that, in case no one ever told you, is a cubic function, because that's cubed. And now we'll just come over here, talk about what's going on. Let me get into some calculus very briefly. Don't shut me out here. At the origin, technically the slope is 0. So it's doing this thing where it's like increasing, and then it, for the briefest of moments, it flattens out and then it increases again. So when I get here to increasing and decreasing, I'm obviously not going to have anywhere where it's decreasing. This graph never goes down, but it actually has one brief point where it's not going up. It goes zoop, stop, up, okay? And that happens at 0, 0. So that's just a technicality. We'll get there in a second. Getting ahead of myself. The domain of this is negative infinity to infinity. Here's why. Any x value you pick here has a corresponding graph to it somewhere. You may have to go down off the board or up off the board here, but it's there. Negative infinity to infinity. The range, negative infinity to infinity. Where is it increasing? Like everywhere. So it's always increasing. So from negative infinity to 0, again, that's because at 0 the slope is like this. It's a calculus thing. It's really fun. We'll put that with this one, so 0 to infinity. Some teachers may just go straight from negative infinity to infinity on this one and not talk about what happens at 0. That's a technicality we're not going to delve into right now. That distracts us from the bigger idea of learning this shape at the moment. Okay, so decreasing, none. There are no intervals where that takes place. Where is it positive? Well, here above the x-axis. So from 0 onward, so from 0 to infinity. When I say infinity, I do want to point this out. When I say infinity, I'm not talking about going up. I'm talking about going over. And as I go over, I'm going up. All right, so where is it negative? From here over. It's going down, but negative infinity to 0. Negative infinity to 0. Okay, there's the third one. There are two more. The next two we're going to go even faster. This one slowed us down a little bit. Here goes. The next one. If I erased and you weren't ready for me to erase yet, don't panic. You can pause the video and go back. That's the beauty of this. But I'm going to keep moving. There's my marker right there. And I know where this one's going, so we'll just put 2's there. We're not going to have any negatives. So, you know what? I've already blurted out part of the answer. This graph that I'm about to do, let me show you what it is. It's the absolute value, and it's not been translated. I just wiggled my arms, meaning this. It's going to be sitting here, and it's not going to move around, which means it's not going to go to the negative side. So if you come over here, we can go ahead and write this. Because it's absolute value, it makes it positive. So there are no areas, no intervals, where it is negative, because we haven't slid it down there. Okay, the absolute value of negative 2. Absolute value makes things positive. We use it when we talk about distance. Okay, so distance or area or things that can't be negative. So absolute value of negative 2 is 2. Absolute value of negative 1 is 1. 0. Keep it positive if it's already positive. If you're walking forward, you're going a positive distance. If you're walking backward, you're going a positive distance. Okay? This actually is sort of like a line that got broken and flipped up. So 0, 1, 1, 2, 2, 0, 0, negative 1, 1, negative 2, 2. So normally we had the line, like the very first one we did, had a line that went up like this and then down, but it got broken, and now everything that was negative is positive. And it looks like that. It's a V, absolute value. I'm not going to write down exactly what we call it because we call it absolute value. The domain is from negative infinity to infinity. The range, I don't know if this is bugging you or not, but there, missing half of a colon. It'll give you some digestive issues. That was a joke. The range is from 0 and up. I'm looking at what y values I'm going to use. So as I glance at it, I say, well, I'm just going to go looking at the y-axis. From 0 and the graph goes up. So 0 to infinity. It does include 0. Where is it increasing? It's increasing after 0. So from 0 to infinity. Where is it decreasing? From this piece, negative infinity to 0. If you're wondering about the parentheses here, it's because at 0 it's neither increasing nor decreasing. Some people will put brackets, and those teachers probably don't count it wrong. All right, positive. Where is it positive? Well, everywhere except at the origin, because at the origin it's neither positive nor negative. So negative infinity to 0, it's positive here, and it's positive here. So union, and then 0 to infinity. But that would not include 0. Okay, let's do one more. And I'm actually going to change the numbers over here for this one. So pause the video if necessary. I'm going to put negative 9, negative 4, negative 1, 0, 1, 4, 9. Okay, knowing where this graph is going, what it's going to look like, I'll go ahead and draw the appropriate numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Trust me on this. That's all you'll need. Let's erase some stuff here. Let's make sure we keep our entire colon. At least part of my colon. Okay. Oh, let's write the function. Last one. There, square root of x. This is the square root function. It's another typical parent function. And again, parent functions are things we should be familiar with. If we know what the parent looks like, then we can sort of figure things out what the kid would look like. So let's start at the bottom on this one. The square root of 9 is 3. The square root of 4 is 2. The square root of 1 is 1. The square root of 0 is 0. The square root of negative 1 is 0. Okay, square root of negative 1 takes us into a realm of imaginary numbers, which do exist, by the way, and I'm for real. Imaginary numbers are real and legit. Random thought, I'll keep this quick. There's a formula that is used in electronics or like electronic engineering, that sort of thing, and it has this in it, and it is a real thing. Like it actually will shock you. Like the electronics and the electricity behind it will, it is a real thing. So when people are like, ooh, imaginary numbers don't exist, oh yeah, they do. They do. We just don't use them normally. Nevertheless, the square root of negative 1, being an imaginary number, is something we can't graph on this plane. So we're going to say that there's nothing that happens here. The square root of negative 4, the square root of negative 4, what's that? Square root of negative 9, what's that? You can't take the square root of a negative number, not really. So for these, your calculator would say error. I'm going to be consistent with what your calculator would say. It might say non-real answer. I'm just going to sort of write this for now. Let's not argue over the specifics of the way it's worded, but the fact is, I can't plot these points. So I'm not going to go over here to negative 9. Negative 9 comma what? I don't know. So no. So this graph is not going to exist on the negative side. So go ahead and tell you the domain is not going to include any negatives. So let's keep graphing here. Let's use green just because. 0, 0, 1, 1, 4, 2, 9, 3. Oops, 4, 2. There we go. Yeah, that's right. And it looks like this. I missed the dot there, but it's close enough. If you really care, I hope you do, it's actually a parabola that got flipped over like this, but we don't have both sides to it. And that's a different lesson altogether. But anyway, it's kind of like a parabola, and it got reflected diagonally. Okay, the domain starts at 0 and it moves forward. So it's from 0 to infinity. The range, what y values am I using? From 0 and up. Okay, so 0 and up. Where is this function increasing? It's always increasing. Now it looks like it's leveling off, so it's increasing at a slowing rate, but it is still increasing. Like you're driving up a hill and you're driving up the hill, and like it's an infinite hill and it just continues to do like this, but it's still increasing, and that happens from 0 to infinity. Where is it decreasing? There are no intervals where it's decreasing, so none. Where is it positive? Well, everywhere that it exists. So, other than 0. So it exists here. It is positive for all x values that are positive. So 0 to infinity, not including 0, because again, at 0, the y-intercept is 0. So negative, none. It's never negative until we go moving it around. So there we go. There are the 5 most common parent functions: domain, range, increasing, decreasing, positive, and negative for each of them.